Hello, welcome to another coding challenge. In this coding challenge, I'm going to explore the traveling salesperson algorithm. It's a classical algorithm that you'll find from kind of this thing known as computer science. I want to talk about what the algorithm is. I want to build a quick JavaScript example to demonstrate how to kind of program the problem, and then I'm going to do several follow-up videos to look at different solutions to this particular problem. And for you, the viewer, I want you to think about what are some creative applications. Could you make some kind of interesting line drawing visual art with it? Could you create a musical system? Could you use it for some sort of data visualization, scientific simulation creative project in your field of interest? So I hope that you'll watch these videos, get the example code, play with it, and make an application with it, and share that application with me, which I might share then with other people, but whatever, that's not the point. The point is, let's talk about this algorithm. So this is currently a processing sketch. I'm going to program this in JavaScript, which is checking every single possible solution to what? So let me walk the traveling salesperson. So, you know, I think that Pokemon Go, in the future, some many years from now, when somebody's watching this video and Pokemon Go is the most irrelevant thing, it'll be so annoying to watch this, but the problem is, let's say you have a space, and this could be a two-dimensional or a three-dimensional or an n-dimensional space, but we're going to work with a two-dimensional space. And the problem is usually framed as there are a bunch of cities. So here are several cities, a map of a bunch of cities, or perhaps they're a map of a bunch of Pokemon that you want to catch. But you're a salesperson, and you want to go sell your, coding rainbow stickers or t-shirts or whatever in every city. So, I could go here, and then I could go here, and then I could go over here, and then I could take the train here, and then I could fly here, and I could go here, and I could go here. And you could see that would be a path that hits every single city, but it wouldn't be the shortest path. And I could try to eyeball it, and this might be an interesting application, by the way, idea. What if you build a computer algorithmic system solving the optimal, fastest solution, and you have it compete with a person trying to draw that solution? That could be an interesting interactive exhibit. But we could try to say like, oh, well, maybe the optimal solution is something like this. But that's just kind of a guess. So we don't have to guess. I could go back over here, and this is a program that checked every single possible solution and this is 12 points. Now you might think, big deal. How many possible ways are there to explore, how many possible ways are there to connect 12 points? Well, there's actually quite a few, and and let's kind of explore that for a second. So let's say there are only 3 points, and the points are A, B, and C. Well, let's look at all the possible ways. A, B, C, A, C, B, B, A, C, B, C, A. I'm doing this in a specific order for a reason, which will become relevant in a future video. C, A, B, C, B, A. And if I did this correctly, these are actually sorted in alphabetical order, which is a kind of piece of this that's going to come up as I explore this further. So you can see, did I do this right? There were 3 possibilities, and there were 3 cities, or 3 Pokemon. There are 1, 2, 3, 4, 5, 6 possibilities. So the way you can actually calculate how many possibilities is 3 times 2 times 1, which is also known as 3 factorial. And why is that? Because there are 3 possibilities for the first letter, and with each one of those, there are 2 possibilities for the second, and for each one of those, there's 1 possibility for the third. So actually, if there are 12 points, there are 12 factorial possible ways of connecting all of those dots, which, if you pull up your calculator, is a really, really big number. And when you go to 13, it's a really big number. So actually, like if I change this program right now to try to use like 20 points, watch how slowly it's going to complete all the possibilities. We are going to be here till the dawn, till the time the sun envelops the earth, and we won't be alive then, I guess. But you get the point. This is going to take a really long time. And if I even just go, let's just go from 12 to 13 just to make this point a little bit more explicit. You can see now, come on, computer. You can see that it's still checking all the possibilities, but even just to get to 1% of the possibilities is taking quite a while. And this is a program that's written in Java that's running relatively fast. Okay, so People in the chat are posting the answers to these factorial questions. I'm glad because I don't have them. I don't have those numbers in my head. So now let's start to program. How do we think about this program in a visual simulation? This idea in a visual simulation. So I'm going to move out of processing. You'll be able to get this Java-based processing code also in this video's description. But I'm going to quit processing here. I'm going to don't save that, and I'm going to work in the browser, which admittedly, JavaScript, HTML5 Canvas is not the place where you're going to find your greatest power and speed from your computer, but it's a place that we can kind of explore this idea. And so what I have here is a simple JavaScript program. It makes a canvas, and it has a draw loop. So what I'm going to do is I'm going to create an array, and I'm going to call that array cities, but this could be anything. Please think more creatively. What are the things in your world that you need to find a pathway through? And then what I'm going to do is I'm going to say, let's just have 3, just to be simple about this. I'm going to have 3 cities. I'm going to say cities index I equals create vector, and I'm going to create a random vector, and I'm going to do this as a separate line of code. Random width, random height. So a vector is just an object in P5.js. I mean, it's, the concept extends beyond P5.js, but that stores an X and Y position. It does more than that, but that's what we're using it for. And so I want to create a bunch of those, and then I just want to see those points in the window. So I'm going to do that same exact loop, but I'm going to say here cities.length, and I'm going to actually make that a variable, like total cities. So it's something we can vary, equals 3. And then instead, and then what I want to do is say, I want to draw a circle at cities index I dot X, cities index I dot Y. We'll make it circle 4 by 4 pixels. We'll say fill 255 so it's white. And I just want a little bit more room to write my code. And then now I'm going to hit refresh here. Whoops. Hit refresh here, and you can see there are 3 cities picked randomly. Refresh the page, I get 3 random cities. So, and you can see here, if I just now go and say total cities 20, now I have 20. But I want to work with a small number so I can sort of visually see that things are working. Okay, am I recording this? Yes, excellent. All right, so let's go back to 3 cities. Let's make these a little bit bigger so you can see them. And let's also, let's make this a little bit bigger, and I can make the console a little bit smaller. Okay, so now what I want to do is start exploring possible orders. Well, I have an order already, actually. The order that I have is in this cities array. So I could sort of say this is an order, and what I might actually do beyond just draw those cities is draw a path between them. So I'm going to say begin shape, end shape, and instead of drawing a circle at each point, I'm going to say vertex, cities x, y, and I'm going to say stroke 255. I'm going to say stroke weight 2 just to give it a little bit of thickness so it's a little easier to see. And I'm also going to say no fill. And so now I'm going to run this, and we can see, there we go. Now, I just realized something. What I want to do is shuffle the array. So what I want to do is I want to try, these are, now I'm getting random every time I refresh. But what I want to do in that draw loop, is I want to shuffle that array to try different random orders. So how do I do that? So I have a feeling if I go and look up the Mozilla documentation for the array object in JavaScript, there might be a kind of function that's part of the array prototype. Whoa, what's a prototype? Did I just say prototype in a video? But in other words, when I say prototype being this sort of like thing that is in charge of every array that's ever made ever in JavaScript, and there are some functions that I've explored in other videos like remove or splice or push that allow you to manipulate that array. I'm wondering if there's one that's called shuffle. But whether or not there is, I'm going to write my own function. So I'm going to write a function, and I'm actually going to call it swap, not shuffle. And you'll see what it's going to do in a second. It needs an array, and it needs 2 index things. So something that's going to be very useful in just about every scenario that I explore, the traveling salesperson, is this idea of a swap. And this comes up all the time in different things you might want to program and do. So in other words, A swap is if I have an array that says A, B, C. What if I want to pick two random elements, like, oh, this one, and I want to swap their position? So now the array is CB. And I might use this, if I do this with a genetic algorithm, later as a mutation. So the mutation of a path through all the cities is swapping two cities randomly. So let's look at how I might do that. And I am going to say, well, so what you would think you might do is say A index I equals A index J, and A index J equals A index I, right? This is the idea of a swap, oops, A index I. This is the idea of taking an array and swapping two elements, right? Put the element number 3 at element 0, and put element number 0 at element 3. The problem is, if I set A index J equal to A index I just reset A index I to A equal J, so I'm actually setting A index J to itself. So in order to perform a swap, I need to say this actually. I need to have some temporary variable which holds A index I. So I keep track of what A index I is, and then later, once I replace A index I with J, and then J can be equal to temp. So this is just a really simple algorithm for taking two elements of the array and swapping them. And let's look at what happens now if what I do every time through draw at the end is I say swap cities, and then, oh, I need two random indices. So I'm going to say I equals floor random cities dot length, and J is also a random value, so I'm going to swap I and J. And of course, I'm not guaranteeing that I don't pick the same one and swap an element with itself, but big deal, it's going to do this a bunch of times. Let's run this program again, and you can see, with 3 things, there's not a lot of order possibilities, but if I make this total cities 10, you can see how elements are being swapped, and so it's doing this very fast, but I'm exploring a whole lot of possibilities. Okay. So now, what can I do? What I want to do, just to kind of explore this in a brute force way, is as I'm trying all these different possibilities, I want to calculate what is the distance traveled through this particular order, and if that distance is the best one I've gotten so far, let's save it. So let's do that as the following. So one thing I need to do, I think it might be useful to write a function that calculates the distance between every point in an array. So I'm going to write another function down here at the bottom, and I'm going to call this function calc distance, and it's going to get a list of points. All right, so I'm getting a function, it gets an array of points, and the whole point of this function is now to return the total distance between all those points in the order that they are. So I need some sort of sum that starts at 0. I need a loop where I start at 0. I go all the way through the length of that array, and I say what? So if this is my order, I want to know this distance plus this distance plus this distance plus this distance. So I always want to know the distance between I and I plus 1. And then this becomes I and this becomes I plus 1, et cetera, et cetera. So if I come back here, I'm going to say var d equals distance between points index I dot x, points index I dot y, points index I plus 1 dot x, points index I plus 1 dot y. Okay? And then I'm going to add that sum plus equals d, and then I'm just going to return the sum. So, by the way, this is a function in P5 that calculates the distance for you between 2 points. So I'm giving it points index I, x and y, points index I plus 1, x and y. So that should be the distance. Now, later I'm going to optimize this because this is actually going to be kind of a slow operation to calculate distance. And there's a way later that I could speed this up, and when I'm trying to do this zillions and gazillions of times, speeding it up could be a good thing. Okay, now what I'm going to do is I'm going to say, I want to have a variable called record distance. Now, so the first thing I want to do is whatever order this array is calculated in first, I want to know calc distance of cities, right? Calculate the distance for this array cities, and then the record distance is that first distance. So I'm going to get a random set of points. I'm going to get a distance between those, and that's my best so far. Then remember down here, I did a swap. So I shuffled it around. So once I did a swap, let's calculate that distance again of cities. And then if that distance is less than the record distance, then record distance equals that distance. So this is me just checking all, like randomly swapping things around. This again is not going to be an efficient algorithm for solving the traveling salesperson. I'm building it this way just to show what the problem is and how kind of impossible it is to find that optimal solution with a certain number of points. So what I want to do here is just say console, whoops, what I want to say is console.log record distance. So we can kind of look at these values as I'm finding them. So let's run this program now. Oops, sketch.js line 55. What mistake did I make? Points, okay. I get a list of points. Of course, I meant to, I made this mistake on purpose and because I wanted to correct it later and then I forgot about it. So what's the problem here? Remember, I'm checking in the array, element I, and the next one, I plus 1. So I can't go to the end of the array because if I go to the end of the array, there's no I plus 1. There's no element after the end of the array. I don't actually care because that's the end of my journey. That's the end of my traveling to catch all my Pokemon or whatever I'm doing. So later somebody will dub this video over with whatever is the newest thing, like, never mind. I don't know what the newest thing will be. It won't be Pokemon. It'll be Schwule Batatan. Okay, so I need to add a -1 here so I don't go to the last one. Okay, now we can see I'm getting these nice, so far I had a distance of 105, which was the record, and at some point it got a distance of 76, and then it got a distance of 19 pixels through all of those points. That seems kind of insane to me. That must, I don't know if we're ever going to beat that record in a while. So let's run this one more time and see, like, yeah, so you can see it's optimizing. Now I'm not saving what that optimal path is. So that's the next step that I want to look at. So I might need your help in the chat here. I'm not really a JavaScript programmer. That's a confession I have to make to you. And I feel like let's look actually. So there must be a way. One thing I want to do is make a copy of an array. I'm going to need to be able to do that. Because if I have an array with an ordered list of vectors, I want to be able to like save a version of that if it's a really good one. And I could write my own function to copy an array, and I'm kind of tempted to just do that to know that it works. But let's take a minute in this video to, and somebody in the chat will, oh, did I forget return sum? Oh, thank you. No wonder. This is a big bug I just had, by the way. Somebody in the chat just mentioned I had another bug where I was returning D, which makes no sense at all, because I'm just returning the last distance, which of course, why that value didn't make any sense. So return sum is correct. So let's run this again to take a look at it. There we go. These values make much more sense, right? So you can see like it's thousands of pixels between all these points, and you can see the best one that I've gotten so far. Okay, so I'm running that now. Let me go back to what I was doing. So I'm going to go to Mozilla developer doc array, something like this. I'm Googling that to get to here. And what I want to look for is like, what are all of the available functions? Things that I've used. I've used push, which is a function in an array that adds an element to an array. Reverse, ooh, I might need to use reverse later. Unshift, there's so many things I might use. But I'm looking for one, I think slice might do this for me. The slice method returns a shallow copy of a portion of an array into a new array object. Let's explore if this is what's going to work for me. So I'm just going to go over here. This is how I like to figure things out. I'm going to go into the console here while this is running, and I'm just going to make an array that's like 1, 5, 6. And I'm going to look at that array. It's 1, 5, 6. Now I want to say b equals a dot slice. What does that give me? B is also 1, 5, 6. That's good. That's what I need. What if I say now b index 2 equals 7? 157, and A is still 156. So this should work for me, and I believe shallow means because I'm actually not putting numbers in there, I'm actually going to put arrays in there, vectors in there, that it won't copy the vectors. It's just going to copy the array, and that's exactly what I want, because I want to keep that same list of vectors. It's just the arrays are pointing to the same vector object, but in a different position in the array. So this is going to work perfectly for me. So hopefully I got that explanation right and things are going to work. People in the chat are giving me good advice about shallow copy. I might have messed up that explanation. I'll correct it as I continue to talk in this video. Yes, you are watching a video of a person teaching about programming who really does not know what he's doing. Okay, so let's come back and let's say what I want to do is I'm going to say best ever. And what I want to say here is best, there was a show that I used to watch back before, when I watched television, which I don't have time for anymore, which was called Best Week Ever. So this is best, I guess that's from, there's the whole Simpsons thing, best, anyway, whatever, never mind. Best cities path ever is cities to start. And then every time I find a record, I want to actually say dot slice, I want a copy of it. And then every time I get a record, I want to say best ever is cities slice. So just to see if this is working, what I want to do is I want to draw the path twice. I want to draw the current cities and I want to draw the best ever. And I'm going to make the best ever thicker and some pinkish purplish color. And I'm going to make the current cities thinner and white. So let's run this. Yeah, this is working. So I believe this is doing what I wanted to do, which is just randomly swapping things, and every time, and we can look here and see that, I took the print line out, but you can see the pink path is currently the best path that it's got. Now, with 10 points, I can see here, like, this is no good. Like, over here, this part is, like, terrible, because look at them crossing. I could easily, myself, just design, like, go here. I can't do this, like, people who do the weather on television are like so good at this. I could go here, then I could go here, then I could go there. Anyway, you could see how you could easily design a more efficient path. So this isn't going to get us that most efficient path. That's what future videos that I'm going to go into the next steps are going to explore. But let's just see that this program is working by just having 4 points, because I think we can probably visually see that looks like the best path between those 4 points. Same there. It looks like it's kind of finding it rather quickly, right? You can kind of imagine, arguably, is it going to be better? I don't think so. But you can see it's going to randomly kind of try every possibility with just 4 points rather quickly. We can even try 5 cities, and you can see that it's kind of finding it. So, if I slow this down, if I draw it more artistically, if I allow the user to interact with it by adding points, that's sort of an interesting thing, right? These might be some things that you can explore. So I'm kind of finished with this first video demonstrating the traveling. I don't know what the bell does, but it's a thing. With this traveling salesperson problem. In the next video, what I'm going to do is show you how to not just randomly swap points to try a bunch of different possibilities, but actually sort an array of numbers with every single possible permutation, so we can actually just try every single possibility in order, which I think has some kind of interesting creative applications to it as well. So I'm going to do that in the next video. Okay, so thanks for watching this one, and the next video will follow up on this. Okay, talk to you soon.